So we're moving on to chapter 4, and today we're going to be talking about solving systems of two linear equations by graphing. So the solution to a system of two linear equations and two variables is an ordered pair that satisfies both equations. So let's verify that 5, negative 3 is a solution to the system 2x minus y equals 13 and y equals x minus 8. And of course, we've done this before, but now we have to do it with two equations. So let's take the first equation and plug 5 in for x and negative 3 in for y. So we get 2 times 5 minus a negative 3. And we need to know if that equals 13. So 2 times 5 is 10. Subtracting a negative 3 is adding 3. And 10 plus 3 is 13. So I think we can pretty clearly see that it does work in the first equation. Does it work in the second equation? Well, let's find out. In the second equation, we have y equals x minus 8. So we have negative 3, and we need to know if that equals 5 minus 8. And of course, 5 minus 8 is a negative 3, so yes. So since it worked in both equations and we ended up with identities, that means that 5, negative 3 is a solution to the system of equations. Okay, so how do we solve these by graphing? Well, notice our solution is a point. So let's think about what lines look like. If we graph them on the same graph, if they intersect, the point where they intersect is the solution. So then, of course, you have to check and make sure it works in your equations. So if the lines intersect, we have a situation like this, where we have one line and we have another line, and the solution is whatever that point where they intersect is. Now, if the lines are parallel, what happens, I'll go over here on the right side, is they never cross each other. So there's no solution because they never touch. And if what we have is the same line, which means when we graph them, they lie right exactly on top of each other, then the system has infinitely many solutions. So that one goes with that option. So let's graph these. We have y equals 3x minus 4. So remember, we can graph that by using the slope and the intercept. So for y equals 3x minus 4, our slope is 3 over 1, which, remember, since it's positive, means up 3 and to the right 1. And our y-intercept, which we call b, remember, is negative 4. So we start by graphing the negative 4. And then from there, remember, we go up 3 and to the right 1. And up 3, right 1. And we can do that as many times as we need to get our line. And of course, all we have to do is connect the dots. So there is our line, y equals 3x minus 4. Now, the other one is not in slope-intercept form, so we should put it in slope-intercept form by subtracting the 6x, which means we have negative 2y equals negative 6x plus 8. And then, of course, we have to divide everything by negative 2. So we have y equals negative 6 divided by negative 2 is 3x. 8 divided by a negative 2 is a negative 4. So we have 3x minus 4. So if we graph that, that means we have a slope of 3 over 1, which means go up 3 and right 1, from our y-intercept, which is negative 4. So if we graph that, we put a point at negative 4, and we go up 3 and over 1. So hopefully what you're noticing is that the points are the same, and indeed our line is exactly the same. So the red one is 6x minus 2y equals 8. You can also see, I hope, that they're the same line, because after we got the second one in slope-inter form, the equation was exactly the same. So you should try number 2 and number 3 between videos, and we'll cover those in the next video for this section.